Alright, welcome back 8th graders. So in our last video we talked about cylinders. That's where we have 2 circle bases. A cone we only have 1 circle base. It's almost like a circular pyramid. So let's move on. You know cones like ice cream cones. That's a very common cone. Alright, so parts of a cone. You have the base, which again, in this case, is a circle. You have a vertex, that's this right here. Kind of like that vertex to an angle. This is the point furthest from the base. Alright, and then we have a lateral surface, and this is going to be our curved surface. So that would be, lateral surface is basically all of the cone piece of it. Our slant height is the distance from the vertex to the base. So distance from vertex to the base. So in this case, that is this right here, vertex. Oops, not that I drew it straight, but that's our slant height. And then if we have to talk about height, that's the length of the perpendicular segment from the vertex to the base. So, oops, helps if I could spell today. Length of perpendicular. Remember I told you perpendicular is going to be an upside down T segment. From vertex to base. So, from a cone, if we were to drop a line straight down, that would be, so this is our slant height, whereas this one is just our height, or I would call it our, perpendicular height. And so these are the different pieces of a cone. How do we find the surface area of a cone? Well, in order to find the surface area of a cone, remember we need to add up all the different sides of the cone. So we would have the circular base, so that would be the area of the circle, otherwise known as pi r squared, plus our lateral area, because there's nothing else, it's just the circle and the lateral area. So area of the circle, pi r squared, and our lateral area. And the lateral area is going to be pi r L. Right? Because it is not using the perpendicular height, we don't need the 2 pi r, that lateral area is just pi r L. And so other things you need to remember, r equals radius, and in this case this cursive L is what we use for slant height. And the way I always remembered that is that the cursive L is slanted just like our slant height. So our surface area is going to be pi r squared plus pi r slant height. And I know I draw L, but I will always call it slant height just because we automatically think of r as radius, but we don't automatically think of L as slant height. And so I say it so that it becomes automatic. Alright, so we're going to do an example. A florist shop is designing a new cone shape arrangement box to the nearest square inch how much cardboard will be needed to make each box. So square inch means round to the nearest whole number. We need to know our radius and our length. Thing is they give us diameter or length. Our slant height. Thing is they give us diameter being 10 inches. So the radius is going to be 10 divided by 2. I don't know why we end up with radiuses of 5. That just is how it tends to be, I guess, or for examples at least. And then our slant height here, this is our L. It's going to be 15. So now I just plug in. Surface area, I don't know why that didn't look like an A at first, is pi r squared plus pi r slant height. So we're going to get pi times 5 squared plus pi times 5 times 15. Like I said before, I don't multiply by 3.14 until I get to the end. It just, to me, I can work faster thinking of pi almost like a variable and combining like terms where viable, as opposed to having to multiply it by 3.14 and having to keep track of the decimal all the way through. So 5 squared is 25. So right now I have 25 pi plus 15 times 5 is 75. So right now we have 25 pi plus 75 pi. I was getting ahead of myself on numbers there. 25 plus 75 is 100. So right now I have 100 pi. So we're going to take that 100 times 3.14, and we're going to end up with approximately, because we're using the approximation of pi, not pi. We end up with approximately 314 inches squared. So, found my radius, found my slant height, plugged in for R and L, and then just used order of operations. Basically, we're just going back to order of operations. If you can do PEMDAS, then you can do this. And that is how we find the surface area of a cone. In our next video, we're going to find surface area of spheres. I will see you there.